This is Bob Capetta from the College of the Florida Keys, and this lesson is on solving systems of linear equations by elimination. So we're going to give two equations of lines, 2x minus 3y equals 3, and 5x plus 2y equals 17. These are two lines. These two lines will likely intersect somewhere, and we want to find that point of intersection. So how are we going to do that? Well, we're going to eliminate the x's. You'll notice I have 2x and I have 5x. And I'm going to ask myself, well, what's the least common multiple of 2 and 5? And the answer to that would be 10. So I want to make both of them 10, but I want one negative and one positive. So how am I going to do that? 2x minus 3y is 5. 5x plus 2y is 17. Let's go ahead and change that minus to plus a negative. And I said I want to make both of the x's 10, but I want one to be negative. So what do I multiply 2 by to make it 10? Multiply it by 5. Now 5 times 2x is 10x. And I want this to be negative 10x, so I'll multiply that by negative 2. And now it's time for us to distribute. 5 times 2x is 10x, plus 5 times negative 3y is negative 15y, equals 5 times 3, that's a 3, not a 3y, equals 5 times 3, which is 15. Down here, negative 2 times 5x is negative 10x. Plus negative 2 times 2y is positive, no, it's negative 4y, equals negative 2 times 17, which is negative 34. So if I add these together, what do I get? Negative 10x and positive 10x will give me 0. Negative 15y and negative 4y is negative 19y. And 15 subtract 34 is also negative 19. So if I divide both sides by negative 19, I get y equals 1. So by eliminating the variable, I've solved for 1. Now it's relatively easy to solve for x. If I get a nice number that is not a fraction, I usually just plug that in to find the other value. So pick your favorites of these two. Maybe I'll pick the second equation. 5x plus 2y is 17. I'm going to plug the y equals 1 in for y here. So it will be 5x plus 2 times. We said that y equals 1 equals 17. So I get 5x plus 2 is 17. And then we subtract 2 from both sides. 5x is 15. Divide 5, and x is 3. So it appears that 3, 1 is the solution, but I believe it's always a good idea to go back and check. So let's look at our original. This was our original. We're going to plug 3, 1 in to see if both statements are true. So going ahead and doing our check, we will say, using 3, 1 as our solution, we're going to check 2x minus 3y is 3, and we'll check 5x plus 2y is 17. Plugging 3 in for x, 2 times 3, minus plugging 1 in for y, minus 3 times 1. Does that equal 3? 2 times 3 is 6, minus 3 times 1 is 3. Does 6 minus 3 equals 3? 3 equals 3, that's yes, that's good. Over on this side again, plugging 3 in for x and 1 in for y. 5 times 3 plus 2 times 1. Does that equal 17? Does 15 plus 2 equals 17. 17 equals 17 again, that's yes. So that point was common on both lines, so 3, 1 is the solution to the system of linear equations. Now, for that strategy, I eliminated one of the variables. We can go back and take a look at the first slide here. I eliminated the x's. I had a value for y. Then I plugged that in to get a value for x. That is one strategy, okay? That is not the only strategy. Let's take a look at an alternate strategy. Let's look at the following. 4x plus 3y equals 9, and 2x minus 7y equals -3. I'm going to eliminate the x's first. So let me write these down over here. Separate my page in half. So I have 4x plus 3y is 9, and 2x minus 7y is -3. Let's make the minus 7y plus a negative. Looking at the x's, I want the x's to go away. So I have 4x and I have 2x. What is the least common multiple of 2 and 4? And the answer is just 4. I can make them both 4 by multiplying the second equation by -2. -2 times 2x makes him -4x. Multiply the first equation by 1, and he's 4x. And those will go away quite nicely. So what I get is upstairs we get 4x plus 3y is 9. Downstairs, -2 times 2x, -4x plus -2 times -7y is +14y equals -2 times -3, which is +6. Now add these together and we get 4x, subtract 4x is gone. 3y plus 14y is 17y equals 9 plus 6 equals 15. So I have 17y equals 15. Let's divide both sides by 17. And I get y is 15/17. When I get a fraction, I do not like to solve by plugging it in, because I've got to do all kinds of arithmetic with fractions, and most people struggle with that. What I will do instead is I'm now going to eliminate y's. So this I call the double elimination strategy. So let's write the equation down again. 4x plus 3y is 9, 2x minus 7y, or plus -7y equals -3. And I look at the y values and I ask myself, what is the least common multiple of these two? Is the least common multiple 3 and 7 would be 21. Make them both 21. But make one positive, one negative. If I multiply the first equation by 7, 7 times 3y would give me +21y. Multiply the second equation by 3. 3 times -7 gives me -21y. So now let's distribute. 7 times 4x is 28x. Plus 7 times 3y, that's the one we're going to focus on. 7 times 3y is 21y. Equals 7 times 9, which is 63. On the bottom, we have 3 times 2x, which is 6x, plus 3 times -7y is -21y, equals 3 times -3, which is -9. Now putting these together, what do we get? 21y plus -21y goes away. 28x and 6x becomes 34x. 63 minus 9, I believe, is 54. And then to solve for x, we'll divide both sides by 34. So I get x is 54 over 34. Divide the top by 2, divide the bottom by 2, and I get 27 over 17. So it appears that 27 seventeenths, 15 seventeenths is the solution. That's what it appears to be. That'll be difficult to check, again, because we're going to get very, very large numbers, so we have to plug into that. But if you have a calculator, you can pull that out and see how it goes. So a calculator check, I would say, is the way to do that. So I'm going to do 4 times 27 over 17 on my calculator. I don't know if you'll be able to see it. Maybe. 4 times 27 over 17. 4 times 27 over 17. Plus 3 times 15 over 17. Gives me 9. I feel good about that. 2 times x, 2 times 27 over 17. Minus 7 times 15 over 17 equals -3. So I was able to check that quickly on my calculator, get the same answer that I wanted to get. So I'm confident that that answer is correct. So let's do one more sort of at that level of difficulty where we have to do a double elimination. So let's try it and see what we get. Let's try 5x minus 3y equals 1, and 2x plus 9y equals -4. 5x minus 3y is 1, 2x plus 9y is -4. Again, I'm going to subdivide my page in half, eliminate the x's on one side, eliminate the y's on the other. So we're going to rewrite this as 5x plus -3y equals 1, and 2x plus 9y equals -4. If I want to eliminate the x's, I ask myself 5 and 2, what is the least common multiple? Least common multiple of 5 and 2 is 10. Make them both 10. Make one positive, make one negative. So I'll multiply the first equation maybe by -2. If I do that, that 5x will become -10x. So we get 5x plus -3y is 1. -2 times 5x is -10x. I want this to be positive 10x. So multiply the second equation by positive 5, and I get 2x plus 9y is -4. So let's distribute. What do we get? -2 times 5x is -10x plus -2 times 3y is 6y equals -2 times 1 is -2. Good. On the bottom, 5 times 2x is 10x plus 5 times 9y is 45y equals 5 times -4, which is -20. And you'll see what happens. The x's go away. 6y and 45y is 51y. -2 and -20 is -22. Divide both sides by 51. And we get this very unpleasant looking answer of y equals -22 over 51. And I certainly do not want to plug that in to evaluate x. I eliminated the x's here. I'm going to eliminate the y's on my second version of this. So let me copy it down again. 5x will make that plus -3y equals 1. 2x plus 9y equals -4. Copying down the question properly is one of the biggest challenges here. So what I'm going to do is I'm going to eliminate the y's. 3 and 9, least common multiple is 9. Make them both 9. Make one negative and one positive. So I'm going to multiply the first equation by 3 and the second equation by 1. That'll make this 3 times -3y -9y, 1 times 9y positive 9y. As I distribute, 3 times 5x is 15x plus 3 times negative 3y is negative 9y equals 3 times 1 is 3. 1 times 2x is 2x plus 1 times 9y is 9y plus 1 times negative 4 is, of course, negative 4. Add all these together. Negative 9y and positive 9y go away. I get 15x plus 2x. I get 17x is 3 minus 4 is negative 1. Dividing by 17. And I get x is negative 1 over 17. But I still want to check that to see if what I get is correct. So x is negative 1/17, y is negative 22/51. Let's write that down. X is negative 1/17. Y is negative 22/51. And then our two equations are 5x minus 3y equals 1. And 2x plus 9y is negative 4. I really like to check these to see if what I have is correct. So again, I'm going to pull out my calculator. I'm going to do it a little differently this time. I'm going to take negative 1/17 store in x. If you know how to do that, that's great. And then I'm going to take negative 22/51 store in alpha y. And I'm going to type in my equations, 5x minus 3y. And I hope I get 1, and I did. But I'm going to type in 2x plus 9y, 2x plus 9y. And I hope I'm going to get negative 4. And I do. And it certainly seems to be the case that negative 1/17, negative 22/51 is a solution to the system of equations. And that will conclude this lesson.